The highest mountains in the world, the Himalayas, tower 5 miles above the level of the sea. They seem to have been there forever. And yet, buried high in the rocks, scientists have found fossils of creatures which lived in the sea 100 million years ago. And deep below sea level, scientists have discovered remains of land plants which once grew high above the sea. The crust of the earth is always changing. Mountains are thrust up from the surface of the land. Erosion constantly wears them away. The heat of the sun and the freezing of water act to crack and break up the rocks. Water and carbon dioxide in the air combine to form an acid which dissolves and powders the rock. Blown by the wind, particles of hard rock blast and wear away the face of the mountains. Rain washes the broken and powdered rock down to the riverbeds. Rivers carry these materials to the sea. And the pounding of the sea wears away the land. The highest mountains, thrust up 20 million years ago, are slowly being worn away. The glacier ice will scoop out valleys. All the forces of erosion will wear the mountains down to rolling hills and plains. In 100 million years or more, the material of the mountain will all be deposited elsewhere. This process has continued for at least 3,000 million years. Let's go back in time thousands of millions of years ago. Some scientists believe that the planets were once part of a giant cloud of gas and dust moving around the sun. Large particles captured smaller ones and grew like snowballs, until most of the material of the cloud was concentrated into 9 planets. As one of these planets, the Earth, became larger, the materials at its center became compressed and heated by the forces of gravity. Radioactive material compressed at the center generated great heat, which spread outwards and melted some of the rocky material in the cold outer layers. Over long periods of time, the lighter materials have moved toward the outside, the denser materials have sunk toward the center. The inner core is thought to be composed of solid iron and nickel. Radioactivity probably keeps the deep interior at a high temperature. The outer core is probably composed of the same materials as the inner core. It appears to be liquid. The core is covered by the mantle. The upper region is composed of basalt, a hot, very heavy layer of rock. Deeper in the mantle, the hot rock seems to be plastic, flowing in much the same manner as a jelly. Above the mantle is the thin crust, composed mainly of granite, which is lighter than basalt. The first mountains, huge blocks of granite, floated in the underlying basalt, just as icebergs float in the sea. Underneath the oceans, the crust is very thin, perhaps a few miles in depth. Some scientists believe that the enormous heat produced in the core produces rising currents in the overlying mantle, which bring up hot material from the deep interior. Descending currents bring down cooler material from nearer the crust. Two currents may act together, to compress the elastic crust of the Earth and wrinkle the surface. Such wrinkles are huge mountain chains. These mountains are constantly being eroded. Material from them is washed down to the sea. Layers of the sediment form in the seabed. The pressure of its own weight and that of the water above changes the muddy sediment. In time, the sediment hardens into rock. Millions of years may pass. The sediment layers pile up and the seabed sinks. Through erosion, the mountains gradually lose their weight. Like melting icebergs, they are pushed higher in the plastic basalt in which they float. When the descending convection current ceases, hot material may rise in the mantle. This produces an upward force. The sedimentary rocks may be forced slowly out of the sea. Over thousands of years, they may buckle and fold. A new range of mountains is being built. And yet, even as these new mountains are thrust up, they too are slowly being worn away. New sediments are washed into a new sea. New layers are forming. The cycle is repeating itself. In the ceaseless process of mountain building and erosion, streams and rivers carry material into lakes and seas. Sediments are deposited according to size. The lighter materials, sand, silt, and mud, are deposited further out. In very deep water, little sediment from the land is found. In time, rivers may change their course. The seabed may be forced upward. Newer sediments of a different type are deposited over the older ones. The layers become thicker and thicker. The weight of the mass compresses the layers into rock. Each layer of sedimentary rock helps scientists solve more of the mystery of the Earth's crust. A limestone layer far above sea level suggests that this layer once formed the bed of a sea in which lived creatures now extinct. A layer of gypsum or salt is a clue to a salty lake or sea that has long since dried up. Deposits of coal indicate a swampy region where millions of years ago rich vegetation once grew. These deposits sometimes contain fossil remains of organisms that lived long ago. But changes in the Earth's crust pose special challenges to the scientist. Layers are often broken up or difficult to find. Mountain building folds and twists the sedimentary layers, sometimes inverting them completely. As these layers are thrust above the waters, erosion begins to wear them away. The crust may sink, burying old sediments under newer layers, which are again raised and folded. Sometimes the layers break and slide against each other, forming a fault in the crustal layers. At times, when mountains are being pushed up, earthquake and volcanic activity may occur along a fault. The enormous force moving in the surface rocks releases sufficient heat to melt the underlying basalt. Great pressure from the mantle forces molten rock and gas upward through faults in the crust. The molten rock, or magma, may never reach the surface. Instead, it may spread out between the other layers, heating and changing the rocks nearby. Rocks changed by such heat and pressure are called metamorphic rocks. When magma is forced up along a fault line, it may reach the surface, gradually spreading out over the crust. Under the molten rock, the surface layers may be changed to metamorphic rock. Sometimes the molten rock and gases bursting up through the surface form a volcano. In the center of the volcano is a crater blasting hot materials into the air. In time, broken rock and cinders form a mound around the crater. The mound is often shaped like a cone. Molten rock bubbles up inside the cone and spills down the sides. This rock is known as lava. For a time, the volcano may become inactive. The lava cools and hardens, and then another eruption may continue to build up the cone. New layers of lava cover the hardened layers underneath. Each eruption adds more layers of ash and lava rock. When the eruptions cease, the molten material changes and becomes very hard. It is known as igneous rock. All igneous rocks are formed from materials that were once deep in the earth. Igneous rock resists erosion more than softer rocks around it. Studying the rocks in the Earth's crust, scientists are able to unravel some of the mysteries of changes long ago. Bit by bit, the early history of the Earth is unfolding. Over thousands of millions of years, the crust of the Earth has been shifting and changing. The face of the land heaved and twisted. Mountains formed, and volcanoes erupted. Rains and winds changed the landscape. For millions of years, the rocks were barren and the seas were lifeless. For millions of years, there was still no life upon the earth.